Cyclorotor could be the future of eVTOL electric propulsion system. We shouldn't be surprised one bit at the level of technology that has been stuck at this point. We as humans live in the most advanced era of technology, and most of us are taking it for granted. From the smallest of smartphones to the biggest of airplanes, technology has done us a massive favor by making our tasks easier than before. But even after so many discoveries, many people believe that this is simply just scratching the surface. This is because, with the Cyclorotor, things might change in the vertical takeoff department. Cyclorotors. This technology, which is a century old, utilized in ships, is now being seriously considered to be used in eVTOL electric propulsion systems. eVTOL stands for Electric Vertical Takeoff and Landing. It offers compactness, maneuverability, and a stable transition from hovering to flight. Hovering is only good initially where the Cyclorotor needs to take off the land. After that, a steady flight system needs to come in place, which can help cover the largest of distances with incredible stability. This technology ticks all the boxes. The first thing we need to look at is what Cyclorotors are. Also known as cyclogyro or cyclorotor, this is a fluid propulsion device that manages to convert shaft power into the acceleration of a fluid using a rotating axis, perpendicular to the direction of the fluid motion. This device uses blades that span an axis parallel to the axis of rotation. These blades are fixed twice per revolution to produce thrust in a normal direction to the axis of rotation. The primary use of these cyclorotors is lifting, control on air and water vehicles, propulsion, and control. History. In 1923, Jonathan Edward Caldwell filed for a patent on the device, which he named the cyclogyro. It consisted of an airplane fuselage with two wheel-like paddle attachments that replaced the wings. This was one of the few attempts to create a vertical takeoff and landing cyclocopter aircraft. As noble and inventive this prototype from Caldwell was, it was a brilliant failure. Brilliant in the sense that this technology implemented was outrageous and failed due to apparent reasons. The main reasons the failure of this propulsion system could be accounted for are three reasons: unsuitable materials being utilized, heavy engines and power sources, and insufficient knowledge of aerodynamic phenomena. Unsuitable materials. The materials used to make this prototype could have been picked wrongly. When this technology was applied, the concepts of physics did exist, but they weren't focused on that much. This is why people usually opted for material that would be cheaper and easier to avail rather than something that would suit the propulsion system. This is a significant problem that was faced back then. Heavy engines and power sources. Power is one of the essential things required to work this propulsion system. But back then, rather than focus on size and convenience, the bigger the size of the engine, the more power it was supposed to deliver. As for keeping in mind the entire dynamics of the propulsion system, the engine was supposed to be in accordance with it. Yet, this was overlooked, and the whole structure couldn't handle the engine's massive size. Insufficient knowledge. As mentioned earlier in the part of unsuitable materials, insufficient knowledge was the most prominent drawback of this propulsion system. With people not having adequate knowledge of such technology, it was no surprise that they would face several disadvantages. Caldwell did manage to create a propulsion engine, but he failed to develop troubleshooting ideas. If an issue arose in the cyclorotor, it was usually difficult to fix it. Operation. Cyclorotors produce thrust using a combined action of rotation on a fixed point of the blades around a center, and a fixed oscillation of blades which change their angle of attack over time. The angle of attack is the mechanism that constitutes the floating of this cyclorotor at a balance. The joint action of the advancement produced by the orbital motion and pitch angle generates a higher thrust at low speed than any other propeller made. While hovering, the blades are fixed to a positive pitch on the upper half of their revolution and a negative pitch over their lower half, inducing a net upward aerodynamic force which gives the cyclorotor stability. Work in recent years and cyclotech. In recent years, there have been converging technologies and improvements in lightweight materials. Electric propulsion systems and batteries have reached a point where they have the potential to revolutionize air travel. A cyclorotor has several wings rotating around a central rotation axis at a constant speed, where these wings are connected to a freely rotating hub with conrods. A conrod keeps the entire propulsion system stable from the car, preventing the system from toppling or being knocked over. An eccentric hub position causes a periodic change of the pitch angle attack of wind during a single revolution, thereby generating accelerated airflow and managing to create thrust. Now, an Austria-based company called Cyclotech has completed its first test of an eVTOL prototype, and the test flight has been a genuine success. This technology aims to combine the main benefits of rotorcraft and fixed-wing concepts. This rotor from Cyclotech has an electric-powered VTOL chassis that utilizes Voith-Schneider propellers, rather than using traditional rotors for improved agility and stability in the air. These propellers resemble a vintage paddle streamer, with each propeller looking for a spinning cylinder whose walls are formed by several wing blades. The design might seem familiar to other air propellers that use standard rotors, but this system can be run on various fuel systems such as bio and fossil fuels. Then again, using these fuel sources would limit the maximum potential of this rotor. This propulsion system can also target its thrust in all directions, be it downwards, forwards, backward, or any other direction. This prototype is being tested because it will be used to develop a 5-seat air taxi model. There could be some exciting things in the future from Cyclotech, and with an air taxi in the pipeline, this prototype might change the way we look at air transport. With Cyclotech going all in the VTOL market with thrust vector control systems, the compact rotors allow for precision and stability that is second to none. Even in the harshest flight conditions, this technology is going to deliver. The rotor technology providing a robust cyclorotor system will be incredible for upcoming air taxis. Plus, it will be a massive contribution to environmentally friendly surroundings, since this system will be electric-powered in its entirety. With so much to look forward to in this department, we can't help but be excited for this propulsion system to be integrated into a transportation device. As we said in the beginning, today's technology is only just managing to scratch the surface. With this propulsion technology making loud noises in the air travel sector, airplanes might be the technology of yesterday when air taxis arrive. Something that was looked into almost 100 years ago is now being primed to take over tomorrow's transport. The cyclorotor just might be the device that helps us take to the skies better.